this requires some simplification. So we have x is equal to e raised to n minus e raised to minus n, which can be written as 1 upon e raised to n, divided by e raised to n plus 1 upon e raised to n, right? This can be, now if you take the LCM, you get e raised to n, so it becomes e raised to n into e raised to n square minus 1, divided by much the same way, LCM e raised to n upon 1 e raised to n into this e raised to n square plus 1 upon e raised to n. So this becomes e raised to 2n minus 1 upon e raised to n, and then since this division is the same as multiplying by the reciprocal, upon e raised to 2n minus 1. So this gets cancelled and you have x is this. So now we have x is equal to e raised to 2n. Now that means x into e raised to 2n. Here we have e raised to 2n minus 1. Oh, we have done a mistake here. This is e raised to 2n plus 1. So here it's also multiplying. So it's e raised to 2n plus x is equal to e raised to 2n minus 1. Now, if you see, we need to collect all these terms together. Among the various options, you have log of all these things. So in that case, we need to collect all the e raised to 2n terms. So this becomes x e raised to 2n minus e raised to 2n is equal to minus x minus 1. We can take e raised to 2n common and you get x minus 1 minus of x plus 1. Hence we get e raised to 2n is minus of x plus 1 upon x minus 1, which is draw a line here. Now this hence becomes e raised to 2n. Now we can take the minus as a common factor denominator and you get x plus 1 upon minus x plus 1. In other words, e raised to 2n is equal to 1 plus x upon 1 minus x. So this is the exponential form. E raised to the base raised to some index is this. So that means log of this thing, that is log of 1 plus x to the base 1 minus upon 1 minus x to the base e is going to be 2n. Remember that rule, that if a raised to x is equal to m, then log of m to the base a is x. So e raised to 2n is this. So that means log of this to the same base e is equal to the index 2n. So in other words, now you have to divide both sides by 2. So that means half log 1 plus x upon 1 minus x to the base e is equal to n. So n's value is half log 1 plus x upon 1 minus x. So which is going to be this one. So once again, what you have to do is you just need to simplify this, cancel away the e raised to n, collect all the x terms together. Hence, you get the value of e raised to 2n, because among the answers you have log to the base e. So obviously the e has to be kept as the base. So you rate e raised to something as whatever is the expression in terms of x. Once you get it in this form, change it to logarithmic form. So e raised to 2n is 1 plus x upon 1 minus x, which means log of 1 plus x to the base upon 1 minus x to the base e is 2n. This is a coefficient of 2. Remember, please be careful, don't write it as log of half. Half is going to be the coefficient here. Half log 1 plus x upon 1 minus x to the base e is n. So we have this as a particular option. And yes, that's what works here. Alright, so that was a slightly tricky one, but we need to practice these kind of questions often. Okay, so next we have is 1 upon log. Now we're going to use a rule here which we have not yet used so frequently. So it is 1 upon log ABC to the base AB plus 1 upon log ABC to the base BC plus 1 upon log ABC to the base CA. Now here we are going to use the rule that log A to the base B into log B to the base A is nothing but 1 upon is equal to 1. In other words, log A to the base B is the reciprocal of 1 upon log B to the base A. So if you interchange the base and the power, it becomes a reciprocal. Hence this now becomes actually log AB to the base ABC plus log BC to the base ABC, this one, and this becomes, yes, log CA to the base ABC. Now how do we go from here? Here now we are going to change the base to the base 10. So hence we write it as log AB to the base 10 upon log ABC plus log BC upon log ABC plus log CA upon log ABC. Now here, hence we have this as the LCM. This becomes log AB plus log BC plus log CA, which is log AB into BC into CA, which is log A square, B square, C square, which can be written as ABC the whole square upon log ABC. And we get 2 log ABC upon log ABC. This gets cancelled and we have 2 as the answer here. So let's check this. Hence what we are doing here is just changing the base, taking the common base and then using the rule of changing the index to the coefficient. And yes, we do have this. Okay, so what we have next is number of digits in the numeral for 2 raised to 64. Now here we need to go a little bit of deviation because it's concerned with basically using the log table, but although we may not really need to use log table over here. So we need to find how many digits would we have before the decimal point for this. So you have 2 raised to 64. So what we normally do is we need to find the value of this. So we'll find out what log 2 raised to 64 is. So log 2 raised to 64 is 64 into log 2. 64 into log 2, which would be 64 into 0.30103. So if we multiply this, we have 64 into 0.30103. So what we have is roughly around 19.265 whatsoever, 9.2659. Now, but we are not interested in finding what log 264 is. We are interested in finding out what the value of 264 is. And to nullify the effect, therefore, if log 264 is so and so, 2 raised to 64 is going to be anti-log 19.2659. Normally what is done is we have the anti-log table, we check the mantissa over here and then we write the mantissa. Okay, so suppose the mantissa is turning out to be 3123 or something, suppose it is. After we write this, we need to look at the whole number before the decimal and add 1 to it. So we need to take 19 plus 1, 20 digits, and which is after which we need to put the full stop. So that means this particular answer, that is 2 raised to 64, would have 19 plus 1, 20 digits. So ultimately log 2 raised to 64 is so and so. That means the value of 2 raised to 64 is anti-log 19.2659. At this stage, we are not concerned about what the answer for this, but we need to find out how many digits we would have. The number of digits would be whatever you get in front of the decimal after finding the log, 19 plus 1. So suppose you get something like 6.7523 log of some number. This number's answer will have 6 plus 1, 7 digits. So same way this will have 19 plus 1, 20 digits. So the number of digits in the numeral for 2 raised to 64 would be 19 plus 1, 20. So we have 20 as the answer. So you just have to multiply 64 by log 2. You'll get whatever is the integral part of this whole answer. You need to add 1 to that. You get the number of digits. So there are 20 digits in this particular thing, and yes, we are right. Fine. So this was a little bit of a deviation from the usual thing, but at least a hint of what we need to do in such cases. Let's move further. Okay. So here we have log 8 to the base 3 upon log 16 to the base 9 into log 10 to the base 4. Again, this is all concerned with simplification. So we have, this can be written as log 8 upon log 3 divided by log 16 upon log 9 into log 10 upon log 4. Now this again can be written as log 8 can be written as log 2 cube upon log 3, and since it is divided, all these things will go and this will become log 9 into log 4. This denominator goes in the numerator, divided by log 10 into log 16. Now this needs to be simplified further. We can write it as 3 log 2 into log 9 can be written as log 3 square into log 2 square upon log 3 into log 10 into log 2 raised to 4. This would now become 3 log 2 into 2 log 3 into 2 log 2 upon log 3, log 10 is nothing but 1 into 4 log 2. Rest is all cancelling away terms. You have log 3 and log 3 are getting cancelled, and you have 2, 2 and this 4, and you have log 2, and then ultimately you have everything term gets cancelled, and what you're left with is nothing but 3 log 2, obviously 3 log 2 to the base 10. So our answer is 3 log 2 to the base 10. Do we have it over here? Yes, we have 3 log 2 to the base 10 is the answer for this. And yes, we can reaffirm this. Hence, again, in all this, we are just converting this to a common rule. We have done many earlier sums similar to this, changing the base and converting this to a similar base so that all of them can get cancelled. Okay, now here we have log 144 is equal to so and so. Again, this type of sum we have done here. Log 144 has to be prime factorized. Log 144 is nothing but log 12 square, which can be written as log of 2 square into 3, because 12 is nothing but 2 square into 3, the whole square. If we use the laws of indices, you get log of 2 raised to 4 into 3 square. 2 square, the whole raised to 2, 2 raised to 4. Now this can be written as, using the rule, log of a into b is log a plus log b. Then we use the rule log a raised to m is m log a. So it will be 4 log 2 plus 2 log 3. So we have 4 log 2 plus 2 log 3 as a simplification of log 12 square. So do we have it here? Oh yes, we have 4 log 2 plus 2 log 3. And yes, that's what we have is the right answer. So that is again simplification and expressing in terms of prime factors. Let's take the next example here. We have, yes, we have done this type 2, but a wee bit of a deviation. Here we have an equation. We read it as log of log x to the base 2 log 3, and hence we have it. What we're going to do here is log, and this would remain as it is, and log. So normally in these simplifications we start from the innermost bracket, but now this is going to be an equation, hence it means you need to convert it to the exponential form. So to do away with this log of any number to any base is nothing but whatever is this, that is log of log x to the base 2 to the base 3 would be equal to 2 raised to 1. So log of all this is 2 raised to 1. So we are done away with this, which will turn out to be 2 in any case. That means log of log x to the base 2 to the base 3 is 2. Now further we need to do away with this log, again change it to exponential form. So that means log x to the base 2 is equal to 3 square. So that means log x to the base 2 is 9. We need to find the value of x. Further exponential form to do away with the log, we have x would be equal to 2 raised to 9. And with your calc, you'll be able to find that 2 raised to 9 is nothing but 512. So that means in such a case, the value of x is 512. Right? So, and we do have it the same 512. Okay. Now here we have the next one is log a plus b divided by 4 is half log a plus log b. Now this, then you have been asked to find a by b plus b by a, the value of this. Now again we have come across this thing, so let's first convert the whole thing to log, complete logs on both sides, is equal to half log a plus b, which is nothing but log a plus log b the whole raised to half, which is going to be log a plus b by 4 is equal to log ab, so raised to half. So we need to write it as log ab raised to half, which is the same as log a plus b upon 4 is log of root ab. We have log root ab. Now log of one number is equal to another number, so we remove the whole thing and you get a plus b upon 4 is equal to root ab. Now we have been asked to find a by b by b by a, which is the same as a square plus b square upon ab. So now we need to square. To get rid of the square, we square both sides. So when you square both sides, you get a plus b the whole square upon 4 square. We shouldn't forget this, upon 16 is equal to ab. So in that case, let's see what we get. We have a plus b the whole square upon 16 is equal to ab. So we have a square plus 2ab plus b square is equal to 16ab. In other words, we get a square plus b square is 16ab minus 2ab, 14ab. Now we need to find a by b plus b by a. So you divide, take this ab down. So we get a square plus b square upon ab is equal to 14, which will turn out to be a square upon ab plus b square upon ab, which is 14. This of course becomes A by B plus B by A is 14. We have done similar questions earlier where individual A's value was supposed to be found out also, no? But here we have A by B plus B by A. Just a little more we need to do. Since we want to find A by B plus B by A, obviously collect all the A, B terms to one side and see what they eventually work out to, and you get A by B plus B by A is equal to 14. So among these various values, 14 is the right answer. And yes, 14 is the right answer. Okay. Similar to this, we have this thing. This is again converting both sides and also converting the logarithmic form to the exponential form. So we have log x squared plus x to the base 4 minus log x plus 1 to the base 4 is 2. Now if you see, you're using the rule log a minus log b is nothing but log a upon b. So this is going to be log of x squared plus x upon x plus 1 to the base 4 is equal to 2. Now this one we need to further simplify. If you see, there is an x plus 1 as a factor here. So we can take x common and you get x plus 1 upon x plus 1 to the base 4 is 2. So this gets cancelled. So ultimately it's log x to the base 4 is 2. Now we have to find the value of x. Now this is in the logarithmic form. So you change it to the exponential form. You have x. The log goes away is equal to 4 squared. Mind you, it's 4 squared, not 2 raised to 4. So x would be 16. So among these options, 16 is the right answer. Hence, in this kind of a case, the value of x has to be 16. Yes, and we do have 16.